Good day, students. In this clip, we're going to be going over some examples on how to solve right triangles for the side measures and also for the angle. All right, so before we go ahead and get started, just to do a real quick review on the key formulas that we're going to be using in the problem solving process. The first one you need to know is Sohcahtoa. Sohcahtoa. And we know what these mean. S basically tells you that sine theta is equal to the opposite over hypotenuse. That's what so means. And then cosine theta is the adjacent over hypotenuse. That's what ka means. And then toa means that tan theta is the opposite over adjacent. And these are the side measures of a right triangle. Okay? Let's go ahead and sketch the right triangle. Alright, so there goes your right triangle. Anytime you're doing Sohcahtoa, you know it's relative to a specific angle known as the reference angle theta. Okay, so this is the right angle 90 degrees. So if this is theta, the side opposite the angle is opposite. The side opposite the 90 degrees we know is the hypotenuse. And the other side is your adjacent. Alright, so this is the first set of formulas you need to know. And then the second formula we're going to use is the Pythagorean Theorem, the trig variation, which tells us the adjacent square plus the opposite square is equal to the hypotenuse square. Alright, so these are the key formulas we're going to be using to solve right triangles today. Alright, let's take a look at problem number 1. So for question 1, we're to find x in the triangle below. Alright, the triangle below. Okay, so let's say we have this triangle right here with the following side measures. Let's say this is x, and this angle right here is 50 degrees. 50 degrees, and this side right here is, let's say this is 4, and this is your 90 degrees. Alright, so you're provided with an angle and a side, and you have to find another side. Remember, in order to use the Pythagorean Theorem, you must have at least two sides in the SS situation, but here you have an angle and a side, so you cannot use the Pythagorean Theorem, okay? So to find x, we need to label our triangles. I just want to label the one I know and the one I need, okay? I know this side, so let's name it. This is the side opposite the 90 degrees. The side opposite the 90 degrees angle is the longest side, and is also known as your hypotenuse. Alright, so this is the h in Sohcahtoa, the hypotenuse. This is the reference angle, so the side opposite the given angle or the reference angle is known as your opposite. Alright, so this is our O in Sohcahtoa. This side is your adjacent. I don't need it, and I don't know it, so let's scrap it, okay? So we're just dealing with O and H. So the question is, in Sohcahtoa, we have sine, cosine, and tangent. Which one has only O and H involved in it? We can clearly see that so is what we're going to be using here. So we know that sine theta is opposite over hypotenuse, right? So if we apply that here, this 50 degrees is theta, our opposite is x, and our hypotenuse is 4. So if we put this into so, what are we going to have? We're going to have the equation sine 50 is equal to the opposite, which is x, over the hypotenuse, which is 4. Now we have a trig equation. Let's solve this. In order to solve this, we need to multiply both sides by 4. So multiply by 4, multiply by 4. This 4 is divided out. So the exact value of x is equal to 4 sine 50 degrees. Alright, now let's find what the approximate value of x is also. In order to find this, we need to make use of our calculators. Alright, so let's take a look at this. We're going to enter 4 sine 50, Now, if you're using a Texas Instrument, you have to go to the mode and ensure that your degree format, your angle format is in degrees. Okay, there are three modes there: the radian, degree, of gradient. We need to use the degree format. Okay, and you see this DEG right here clearly shows you're in the degree format. All right, so 4 sine 50 diamond enter will give us the approximate result, which is 3.064. All right, so for today's classwork, you can use just three decimal places. That'll be sufficient. So x is approximately 3.064. This is the exact value. This is the approximate value of x in the right triangle provided. All right, so select this one shape. So there goes your final answer. All right, let's take a look at question number 2. So for question 2, we are to find the value of theta in the figure below. All right, so let's say you have the situation here. This is theta, and then this side is 5. This is 4, and this side is 5, and you have a right angle right here. So we have to find what this angular measure is. All right, so this is a situation where you also have to use Sohcahtoa since it involves two sides and an angle. So let's go ahead and label this triangle. I'm going to label what I know and what I need. What I need is theta is already labeled for me. So what side measures do I know? I know that this side opposite the 90-degree angle is hypotenuse. I don't know it. I don't need it. So let's forget about that. The side opposite the reference angle, opposite theta, is your hypotenuse. I'm sorry, is your opposite. So there goes your opposite. O is Sohcahtoa, and the other side is known as your adjacent. Alright, so we have O and A. So let's write down the formula that relates the sides to the given angle, Sohcahtoa. Now out of sine, cosine, and tangent, which one has O and A? We can clearly see that tan theta is a choice here. So we're going to use tan theta equals the opposite, which is 4, over the adjacent, which is 5. Now, in order to isolate tan theta in this resulting algebraic equation, in order to isolate theta, we're going to take the inverse of tan. And the inverse of tan is tan theta. Alright? So what we're going to do is we're going to take the inverse of tan, both sides. So on the left side, we're going to take the inverse tan. It's tan to the -1, that's how it's written, of tan theta equals the inverse tan of 4/5. Alright, so on the left side, the inverse tan and the tans divide out. So you're going to have theta is equal to the inverse tan of 4/5. Now this is the exact angular measure of theta. To find the approximate measure, we're going to have to use our calculators here. So let's bring out our calculators, and we want to find the inverse tan of 4/5. And my answer is going to be this diamond enter to get an approximate result, 38.66. Alright, so theta is approximately 38.66 degrees. Alright, so there you have it. Alright, let's take a look at the last question, question number 3. So the task is to solve the right triangle ABC. Right triangle ABC. Alright, so what does it mean to solve a triangle? To solve a triangle means that you should find the measures of all the angles and the sides. We're given the measure of one angle and two sides. Now we have to find the measure of the two other angles and the third side. Now since this is a right triangle, we can focus on finding the third side because we're provided with two sides without using trigonometry. Now how can we find the third side given two sides of a right triangle? we can make use of the Pythagorean Theorem. Okay, using the trig variation of that, I can use, let's label it. So this is big B, this side right here is little b, and this is big A, this side is going to be little a, and this is big C, this side right here is going to be little c. Alright, so in this triangle, we're going to use a squared plus b squared equals c squared. We're looking for b, so a is 2, so we have 2 squared plus b squared equals 7 squared. We have 4 plus b squared equals 49. I'm going to subtract 4 from both sides. Subtract 4. And then we'll have b squared equals 45. So isolate b, you take the square root of both sides. And then that yields b is going to be the square root of 45. Let's simplify that. So take that to the side right here. Root 45. Now let's break it down using the prime factors. So we can take out a 5. We're left with 9. Now we can break 9 into 3 and 3. So these two 3's repeat, so they break out of the square root as a 3. So root 45 can be reduced into 5 root 3. So b is 5 root 3. So we have the 3 sides now. Alright, let's go back to our triangle. B is equal to 5 root 3. Okay, now we need to find an angle. So which angle do we want to find first? Either B or C. Well, let's look for angle A, okay? Either A or C. So let's call this theta. Alright, so if we want to call A or theta, then that's what we're going to use to label our triangle, okay? So if A is theta, that means that this side opposite A will be the opposite. Alright, this will be the opposite right here. Let's use a different color so it doesn't look so similar. So that will be the opposite. The hypotenuse doesn't change, but the opposite changes depending on what you want to call your reference angle. So this is a hypotenuse. The side always opposite 90 degrees is always your hypotenuse. And the other side is your adjacent. Now, in order to find this angle theta, we have a lot of choices to make, okay? We can use any pair of sides in Sohcahtoa to find it. But the question is, so we want to find theta, which is A. So the question is, which is the best choice? It's 2, 7, 2, 5 root 3, or 7, 5 root 3. The best choice would be to use the angles that were provided, the sides that were provided in the original question. So the sides that were provided were 7 and 2, so we're going to use those 2 so that just in case our other answer is wrong, it doesn't affect the second result we get, alright? So if we're choosing to use 7 and 2, that means we're going to be using O and A. And in Sohcahtoa, O and A is what? Let's write it down. Sohcahtoa. O and A is your tan. Alright, so that's what we're going to be using here. So we're going to have tan theta, which is tan A, is equal to the opposite, which is 2 over adjacent, which is 7. Alright, now to get theta isolated, we're going to take the inverse tangent of both sides. Alright, so we're going to take the inverse tangent of tan theta equals the inverse tangent of 2 over 7. Alright, and then on the left side, tan and inverse tangent cancel out. Theta is, plug that into our calculators, inverse tangent of 2 over 7. And the final answer is 15.945. Alright? 15.945. So theta is 15.945 degrees. Alright, so that's a measure of angle theta. Let's put it in here. 15.945. Now, the next question is, what is angle C? Now, to find angle C, there are a lot of choices that we can use here. We can use right triangle trick, or we can use the triangle angle sum theorem. Alright, so we're going to opt to use the triangle angle sum theorem because that's much easier and direct. The triangle angle sum theorem tells us that the sum of angles in a triangle add up to 180. Alright, so let's write this down. This is A. A is equal to 15.945. Now to find C, we know that um, angle C is equal to 180, which is everything, minus the other two, which is angle B plus A, because we know that the sum of all the three angles is 180. Alright, so angle C is going to be 180 minus angle B is 90 degrees. 90 degrees, don't forget parenthesis, plus angle A, which is 15.945. Alright, so what we're doing is we're adding these two angles, subtracting from 180 to get the third angle, angle C. Alright, let's see what that is. C is approximately, let's have our calculator do the work for us. So it's going to be 180 minus, don't forget parenthesis, since you're subtracting two angles from 180, 90 plus 15.945. Alright, and our approximate answer is going to be 74.055. Alright, so angle C is approximately 74.055. Okay, so to show that we solved for the triangle, we have to list all our measures. Alright, so our solution are going to be big A is approximately 15.945. Big B, we know is equal to 90 degrees because it's provided for us in the triangle. Big B is 90 degrees. Big C is approximately 74.055. Little a was provided for us. It has a value of 2. Little b is equal to 5/3. And little c has a measure of 7. So if you can list all the three sides and three angles of a right triangle, then you have solved the right triangle as a problem indicated for us to do. Alright, so there you have it. Well, thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel and post a comment to let me know what you think. Click like if you like the clip and feel free to share with your friends. More clips can be found on microsurf.com. Thanks again for watching and have a wonderful day.